Hello all. In this video, we are going to implement the regression tree and random forest using R. We will use real life English Premier League dataset and we will also check how good these models are in out of the sample. So I'm going to call these. I'm going to directly call these data sets. So here is 22, 23. I am not sure if all the data available for the last league. We can check it out. Let me just see. So what I will do, let me first open R. So first what I will do, df say equal to, let me first write rm list equal to ls. So it always a good practice to have that. Start with a clean environment and then data frame read.csv. First what I will do, I will just copy the link address and I will put it here and head equal to true. So yeah, let me run that. So here is, so there are 251 observations. That means English Premier League is all still running, so there not all observations are available. Okay, so not all results are available. So what I will do, let us instead of that, let us take 21, 22 data. So we will take 2021 seasons data and train the model, and we will use 21-22 data to test the model. So let me link address. I will just do that. So this is our test data set. So you can see 21-22 season, we will use it as a test data set. Okay, so you can see that 380 observations are all there. So you can just clean this overall and yeah, now and then df train, sorry, train equal to read.csv, and then we take 2021 data, copy the link address and head equal to true. Okay, so the 2021 series data we will use as a train, and 21-22 series we will use as a test, and we will see what is happening in that. So the first what I will do, so as we have explored this data a little bit before in a previous hands-on, so we know that we have built the Poisson regression model. Let us first fit the Poisson regression model, and then we will compare the performance of the Poisson regression model with the other models, with the regression tree and the random forest. So first fit Poisson regression model. Okay, so fit 1 equal to glm ftag is the target variable, full time, how many goals scored by the home team, and then hst, how many shots are on target by the home team, AST, how many shots are on target by the away team. HC, AC. If we actually go and check the notes, HC is home team corners, away team corners, and then actually we can put many more things. For example, shots target, yeah, and then HR plus AR. HR stands for home team red card, AR stands for away team's red card. HO and offside was not there. Okay, and then bet, we can also take the bet 365. If you go a little bit below, so B365H plus B365 draw plus B365 away teams thing. So this is a betting odds by Bet365 or house, betting house, and we are going to use the train data set. Okay, data equal to df train, and family equal to Poisson, link equal to log. Okay, so if we run this, and summary equal to fit1, if you run this, so what we are seeing that home team shot made by the home team, and home team how many corners they have made has a significant effect, and rest we are not seeing many effect. One possibility could be there are multicollinearity issue. But what we can do before that, we can just do a stepwise selection method to get the best model. So if we just get a sort of a based on AIC, so yeah, now what is going here, that along with home team number of shots on target by home team and number of corner by the home team, we are also getting B365A. That means what is the away team's bet by B365 betting ratio odds, that also playing a role. All right, so we have some model. Let's take this is the model we have. Now what we can do, we can make the prediction for the test data set, the next season's data set. Predict df fit1 comma new data equal to df test, and type equal to response. Okay, now what I can do, I can plot from the df test, what is the HTHG, FTHG, full time goals scored by home team, and predicted values, true predicted values. So PCH equal to 20, pred equal to ylab equal to predicted, and xlab equal to actual. So what we are seeing, that the actual was 7 somewhat it has some power, but and also there are cases where they predicted 15 goals, 10 goals. It's a little bit overestimating, and actual was it was 7. So the model has bit of a overestimating feeling, like here there are cases where it has predicted 5 goals, but most of the goals were under 3 goals. So it is bit of a predicting, overestimating the bias. There is some looks like. So one possible way is also we can do AB line A equal to 0 and B equal to 1. We put like this, then color equal to red, that also. So yeah, so looks like some overestimation, some underestimation. Here there are some underestimations, there are these places there are overestimations are happening. Okay, so this is what we are seeing. Now what we are seeing here is the let us calculate the RMSE, because one of the problem Poisson regression and the Poisson regression is a statistical model, whereas regression tree, random forest are machine learning model for regression. Now what happens in the machine learning models, in these machine learning models there are no likelihood. You cannot write down the likelihood. Since you don't have a likelihood, you cannot calculate AIC, BIC for these decision tree models, random forest models. So you cannot use AIC, BIC type criteria to compare the random forest or decision tree against Poisson regression. So what we can do, we can use root mean square error, which can be used for both Poisson regression as well as for the regression tree and random forest. So we are going to calculate root mean square error for Poisson regression. So RMSE in equal to, so first from the fit 1 we have to take the fitted values out, minus from the df test $ftg square it, take mean, and then take the square root. This is in sample root mean square error. This is for RMSE 1. Okay, and then sorry, I think I have RMSE 1, and then RMSE 1 for out sample. What I have to do, I have to basically, instead of this, I have to take the predicted value. I already predicted it. I have to just go this, and which is 1.26. so in sample there is lot of issues, but in out sample it looks like it is better. That is bit weird, because typically in samples are better than the out of the sample, but we will see how it is doing in the we will see how it is doing in the regression T. Let's check how it is doing in the regression T and random forest, decision tree and random forest. So next we will compare the decision tree regression. we will fit decision tree regression. So in the decision tree, I'm going to use the library called rpart. Okay, and if you come question mark rpart, so it's called recursive partitioning and regression tree. Okay, so you just, it is basically regression tree. It fits the essentially tree function is mainly supported, it follows the Breeman's 1984 quite closely. It says it most detail it follows Breeman et al. And in the main model proposed by Leo Breeman in 1984. So rpart mostly follow that major thing, this paper, classification and regression tree. So this is being implemented in rpart. So I am going to use the classical decision tree regression proposed by Leo Breeman, implemented in R. Okay, so I'm going to fit my second model, the decision tree rpart, and then what I'm going to do, actually, you know what, we are going to have the same model, mod equal to @formula as dot formula, and I can have it, and if I just run it here, I think that will be, yeah, I think it is working fine. So I'll just call this model here. Okay, if you run this model, you can see this is the model I'm going to fit, and data equal to train. Okay, df train, data equal to df train. Okay, now if you run this, so if you now run it, you will see that at the root it is saying what it should does, and then if HST equal to is less than 4.5, it should do something. HST is less than 2.5, it should do something. In this way the decision tree is being made. You can, if you do plot fit to, so generally it plot the decision tree nicely. Let me try. So yeah, it does a decision tree, but for some reason it's not showing the plots. So okay, it's, and I have to say text use n dot true. All right, so I will say text fit to use dot n equal to true. Let me try. Yeah, all right, so it is saying that if HST is less than 4.5, it should go in this way, otherwise it should go in this way. If it is less than 2.5, then with 0.4419 it take a decision. I'm not sure how these guys are doing these things. Okay, let us do the prediction. First, then we will understand how it is doing it. So pred 2 and pred 2 equal to predict fit to new data equal to df test. Okay, if I just do that, and now what I'm going to do, I'm going to just simply plot this guy with grade 2 and let's see how it is doing. Okay, interesting. So the predicted values are somewhat constant, for different two it is not much varying, but it is actually constant, and that's what we were saying, like it should be constant. It takes within a region, it takes some bunch of constant values. But one interesting thing is it looks like it is not overestimating, maybe it is little bit underestimating. You can see that it's going somewhere between 0. The averages are going between half to 4. It's not making much differences. So AB line, if we draw AB line, A equal to 0 and B equal to 1 with color equal to red. Okay, so yeah, it's not, it's bit of a, my feeling is it's bit of underestimating, because you can see that X is taking range, X lim is taking range between 0 to say 10, and Y lim is taking, if I just say the same scaling effect, if we let us see if it, what happens if it is gets, how, see, yeah, so it's not even going up to the 6, 7, 8, whereas in actual values are going up to this, and it has a tendency to a little bit, it is trying to, it is has an underestimation. So that happens, that's fine. Let us do some, calculate the RMSE for in sample and out of the sample. Okay, so RMSE for the second model, and instead of that what we have to do, okay, so what I will do is red, I'll do a y hat here, y hat, and fit to, instead of test I will do train. Okay, let me just here, and then y hat will be here, and instead of test I have to take train, FTHG. Oh, I have to first run the y hat, of course, and then this, and then RMSE2 out, grade 2, and this. Now this out is 1.12, so RMSE2 in and RMSE2 out is 2 out. Okay, so 0.96 and 1.12, whereas it was quite improvement. If you see in sample, Poisson was very high, but in sample it's doing fit. In out of the sample, Poisson is doing still slightly better, 1.26, whereas, oh no, decision tree is doing better because it's going to 1.128, which is smaller than 1.262. So decision tree is doing better than the Poisson regression. Okay, so now finally we will do, but we can see a little bit overestimation as well, because in sample RMSE is 0.966, whereas out of the sample is 1.12. It's slightly overestimation is happening, but in Poisson regression in sample is very high and out of the sample is bit low, so that is also bit of a weird. I don't see why it is happening, but let us see what is there. Okay, so let me fit the random forest So what I will do first, I will call the library. There is a library called random forest. Okay, and now since it will do sort of random sampling of the things, that we will do sample 1 each 2000 comma 1, so 607. This is the set I am going to use. And then what I am going to do, I am going to fit the third model. Instead, copy this. Instead of that, random forest mod. Of course, one more thing, I have to check few things. Random forest, so it's saying y null, x test, y test, and then entry is number of trees that you have to give. So maybe I will give 1000 and see fit 3. This is my third model, and there are some other things are also there. So what I will do, we will let us just keep it in there, and okay, it does very good job. It's very fast, it calculates things very fast. So what I'm going to do, I'm going to copy this, and first thing I will do is predict my predict 3. Okay, and let's see how predict does. Okay, so predict 3, okay, so looks like also some kind of underestimation, because in the 8 the prediction is, in the out of the sample prediction, it is not so high. Okay, so at the higher level it is some kind of underestimation is happening on the model side. Then what I'm going to do, I'm going to calculate the RMSE for the third model. Y hat equal to fit 3, obviously this, and then whatever the TH, this is my third RMSE, this is the third RMSE with third prediction. This is 3, this is 3, 3 and 3. Okay, nice. So clearly the random forest is winning hands down. Okay, so let me write it down. So let me do one thing. Let me just define a matrix called RMSE. Okay, RMSE equal to matrix. Okay, and n row equal to 3, n call equal to 2, call names equal to RMSE equal to in sample in sample and out sample. Okay, so this is in sample, this is out sample, and row names equal to RMSE. Is first model was Poisson regression, comma, second model is decision tree, and the third model is, what is that? Third model is random forest. Okay, and now what I'm going to do, I'm going to put that in the 1. Okay. So yeah, and then I'm going to put that 2 comma equal to this, and finally RMSC 3 comma equal to, and now if I just run, you can see in sample it is dropping constantly. Out of the sample also it dropped, and random forest has won hands down, though we are seeing quite a bit of overfitting in both decision tree and random forest, because out sample RMSE is higher than the in sample, but in out of the sample the root mean square error is significantly lower. Okay, when we plotting this, we are seeing a bit of a underestimation is going on in a conservative side, but random forest is sort of winning hands down. Alright, so that's how typically you do compare across the statistical models and the machine learning models. Remember that comparing Poisson regression with decision tree and random forest is a bit of a unfair, because if you look into the model, Poisson regression model, what I am doing is I'm just fitting a linear hyperplane, and I have not add any engineering model in feature engineering. If I add feature engineering, perhaps possible that Poisson regression model will start improving. Okay, whereas decision tree and random forest, the way the algorithms are being developed, it will automatically try to fit the model in a way the algorithm will capture the non-monotonic non-linear behavior between the x and y in the higher dimension. So this is a very strong, very flexible model, decision tree and random forest. Poisson regression in that sense is a much more rigid conservative model. So in that sense, it's not perhaps a very fair fight. If you want to a really fair apple to apple thing, comparison, probably we have to add few more lines, like feature engineering with HST square plus I and AST square plus I HC square plus I AC square plus I HR square plus I AR square plus I B365H square plus B365D square. So I'm doing some feature engineering here just to check. I don't know whether it will help the Poisson regression model or not, but you can always try some feature engineering. And if you run this and let us see summary, and you can see that some of the features are now, higher order features are now actually quite significant. Now if you run this, and let's see how. So now it looks like doing better. If I run the same model and let us run these models. Okay. And now if I compare, now you see Poisson, after adding the features, Poisson regression is doing even better than the higher order features. Poisson regression is doing better than the decision tree. In fact, it is doing better than even random forest. So a simple Poisson regression can do even better than machine learning model if you add the features, engineered features correctly. So sometimes simple, and the advantage of Poisson regression is the model is completely explainable. You can explain the model why it is happening. Well, decision tree also you can explain. Unfortunately, this plot is not very coming up very nicely, but overall you can nicely explain what is happening here. And yeah, so I think if you just let me zoom that. Okay, so what it is doing, it is basically saying that if HST is less than 4.5, and then you come by this route, if HST is less than 2.5, then you will score a goal with rate 0.4419. If it is greater than 2.5, then you will score a goal with 0.8761. If it is greater than 4.5, then you come this side. If HST is less than 9.5, then you come this way. If the bet 365 is greater than 365 5.37, then you will score a goal with rate 2.219. and if it is greater than that, then you will score a goal with rate 3.944. so that is what it is saying effectively. Whereas, so decision tree is also very good in terms of modeling, but you can see at the end, when we add these engineered feature, okay, we found that Poisson regression is doing even better than decision tree and random forest. But if you don't add this engineered feature, then obviously it is just fitting a simple linear hyperplane, basically straight line in 2 dimension, and obviously it's not doing very poorly compared to decision tree and random forest. So in my opinion, you have to try all kinds of model with feature engineering, and then you have to apply stepwise selection and model dimension reduction technique, and come up with a more parsimonious model, and eventually you will see. And effectively, it is very difficult to say, in my experience, which model will be the best. There is no uniformly best model. In my experience, you should try to fit all the models and see which model gives you the best fit. So with this, I will stop here and see you in the next week, next lecture. Thank you very much. See you.